looking upon a small thing, or you can say a common part that we are using in our daily life, that is a URL shortener. Where we can use it mostly we have created some short URLs. Those short URLs can be shared on WhatsApp. Then there are QR codes that could be generated after that. Okay, based on these shorteners. Logics are almost same. The system design is same for both QR code and shortener. And here we can see the small example or a structure is this. You have a long URL. Then you connected it to your short URL generator. And it produce short URL. So question, today's topic is design, system design for a short URL. So before doing this, let's have some prerequisites. Let's have some questions around this structure. Like what you want to see, and like what is the capacity that you want, like per day, how many URLs that got hit?
10 million, 100 millions.
Okay, let's take an example. We around 10 million, 100 million requests per day. Then question number 2 is mine. What is the what characters do you want in this short URL?
As short as possible.
Okay.
Maybe 4 to 6 characters.
Okay. Characters means like alphanumeric, right? We don't use any special character there. Correct. So we can take like alphanumeric. Then question number 3 will be like you can think about okay, how many do you want to like override or update this thing or delete?
Let's keep it permanent.
Okay, let's keep it permanent. Fine. So these are our prerequisites that we have to handle. Okay.
I have to add one more requisite over there.
Okay.
We should ask for the read and write ratio.
Sorry, could not understand your question.
We should get the data for how many read requests will be there and how many write requests will be there in 100 million daily requests.
Okay. Okay. So these are like 100 million requests. So we can take an example that like read will be 1:10.
We can do that.
Right? 10:1. Okay. So this much is the read. That will be like 10 million into 100 million into 10, that will be like around 1 billion requests, read request.
Okay.
Okay.
Can you explain this how it became 1 billion?
We are taking like 100 million write request for a day.
Okay. I got it. I was thinking we are taking now 90 million as a read request and 10 million as a read request. Okay, it's fine. Anyways.
Yeah. So now these are a question. Let's calculate some back of the envelope. So here are we mostly what we see in the back of the envelope, that what capacity do we need? Okay, we are going to store it for like 1 year. So how much terabyte or space we needed for it? Okay.
Mm-hmm.
So like just take an example. As we are taking 100 million requests per day, so second per second the request will be
Daily we have 84,000 second, 84,600 second. Let's consider it as 10,000 seconds.
okay.
Yeah, so 10 million, 100 million divided by 10,000 seconds.
Yeah, correct. Like around this much. Okay.
Correct. Let's take it as 25 multiplied by 30.
Hmm.
So 25 दिया 75, 75,000.
Yeah. It's round up around. We can take it is around 1100. Okay.
Okay.
Per second.
1100 requests per second.
These are write requests per second.
Mm-hmm.
Okay. And
Read request, na?
these are right because we have taken 100 million here. And
write request should be come, na? Read request will be ज़्यादा.
Yeah. Now read request will be.
अच्छा 1 billion.
Yeah.
Fine.
Into 10. That will be around 11,000
1,000
per second. Okay? Right. Read request.
Perfect.
So this is our traffic around 11,000 to 12,000 traffic per second.
Hmm.
And for writing this 11,000, 1100 seconds, this 10 million, 100 million records, to keep 100 million records, we should calculate like we are keeping it for, take an example, like 1 year. Okay.
Okay.
So for 1 year, it will be like 100 million into 365.
Mm-hmm.
That will be like 36.5 billion. Okay.
Mm-hmm.
So if we convert it to like, if we want to convert this to a bytes, so we can take an character that our URLs, those URLs will be around how much? 10 characters. You can take it 10 characters.
10 to 15.
Sorry, 100 characters. Okay.
100 characters is complete URL, na?
Yeah, complete URL.
One,
correct.
long URL.
Not only that, it is like 100. It is the complete URL. Okay.
Yeah.
So this 100 will be like with it is around 100 bytes. So total space that we needed for this will be around like 100 into 36.5 billion. Billion. Okay. let's convert it to terabyte. 100 into 36 will be around
1.6, 3.6. Huh?
billion bytes to gigabytes.
TB. Let's get it TB.
Let's calculate it to TB.
3.6.
It will be around 3.6 TB. Okay.
Hmm.
So you need this much of space.
Per year.
Yeah, per year. So this much is our calculations.
Hmm.
Okay, so now let's jump to our second things. Let's have some high level designs that we needed for this project. Okay, this URL shortener. What things we should look upon? The HLD will be what things we needed. Like if we can say our first part is API to generate short URL, correct? And second, we need another API which will redirect this short to long. Okay. Am I with you for here till here?
Yes. Yes.
Let's we will create for this a post request. And the post request will have some it has some parameter. Param will be like what param we can take here, like long URL. Long URL, okay. And the return will be a short ID. Are these characters visible to you, or I should enlarge a little bit?
I think it's fine for me.
Yeah, it is fine. Yeah, it is better actually.
Okay.
June 1 is better.
And the second part, that is like data redirect. We can we can explain by the by a diagram. Okay. For redirect, what happened here behind the scene? Let's take this is our client. This is the when the client request as the short URL with a short URL. Okay, like you have your generated long URL. You have generated your short URL by giving your long URL. Okay, now you shared this short with some of your friend. Now that friend will trigger this or try to fetch this short URL, and we should redirect to a long one. Okay, so for that, your friend become our client.
Hmm.
So how that happened? So this is your client, and like let's take this is server one, and this is server two. How we need server two server here? Because this is first one is short URL server. this is the actual server for long URL. Okay, so whenever your client okay hits our this short URL, we will come up with a short URL. Then in return of that, what you will do, this server short URL server will redirect, provide a redirection. That redirection could be either 301 or 302. Okay, what is 301 and 302? Basically, 301 is our permanent. Mostly what happens in permanent redirection, all the clients will cache it. Will cache for a longer time, for a TTL. Okay, and during that TTL, what happened? Your server load will decrease. Fine. This is the benefit of 301, but there is also there are drawbacks also. There is not there, you can't say that it is always needed. Sometimes what happens, you need some tracking, that how many times the user is clicking it, and for that you need to get that links to your servers. For that we use mostly 302. It is for tracking and click behavior. Okay, so we are redirecting based on this 301 302, and here we will provide location in the header, response header, and location response header, there we will provide the long URL. Okay, before jumping here, I want to add up one more part. In the HLD, what we needed, like these are basically these are map, right? Short URL and long URL. So we can keep this in a hash map. Okay, hash map is easier thing to like to find a short and long indexing. Okay, so whenever in the future we need to extract it, we can easily extract it. Now, yeah, yeah,
I have
Vipul.
one question. You said we need to keep both long and short URL in hash format.
Yeah, like the generated short ID could be a hash. Okay,
Mm-hmm.
and in the hash map, in that short ID, we can keep a long URL. Key value pair, in the key value pair.
Okay. Okay. So you were saying we'll keep a key value pair in our database, and key will be the hash value
Mm-hmm.
of short URL, and long URL will be
Sorry, long URL
long.
is the main URL that you have asked for to generate the short on behalf of that.
Long, so I think long URL should be key, right? And value would be short URL, key and value,
That
something like.
yeah, that's your choice, because as you run through a, like you can take this as an example here. Uh, Here this is the short URL generator. Na? What we can do it, we can add up a here a hash function. Hash function. Okay. So this hash function, what it will generate? It will generate for every, like something like a alphanumeric, something like this. Okay. So this key let's take the long URL is like
Table is there up on the right corner top.
sorry.
If you're looking for table on the right, no, here. No, this the last one.
Center page.
Center. Come to center.
Okay, this one.
Yes. It will create those many rows and columns. So if you need 2 row, 2 column, you can just pick that again.
Okay.
Delete that.
No,
Write
no.
another.
There is opacity option. You can make the opacity to be 0. It will be visible behind that. Okay,
Okay,
cool.
no problem.
Cool, no
No.
problem. You are doing good.
Fine. Yeah, something like that. Okay, this is key and this is the value. Okay, and I think we can use it like this. And here what we have like http www.google.com. So this is what I'm saying. Like this can be easily searchable later on.
Correct. We'll make the key as an index.
Yeah. Now this is the type that a hash function will generate for us. Now when we want to go in depth here, you said that this is 301. We are location. We are returning that long URL to it. Then what happens? The client get it. Then client will again take this and hit us with the long URL to the main server. Okay, like what we have here, www.google.com, and we will serve the main page to it. Fine, we are clear till now.
Yes.
Okay.
Yes.
Now there are some important thing that we need to like discuss here. Like as a heap map is basically what hash function map will be saved in the memory. It is good for like a small project, but when we are going for a production level thing like a design, okay, then we should consider saving it in a DB better than in a hash map. So the same table that we have created, maybe some a DB table we can use, which have auto-generated ID. Then this is short URL, and there is a long URL. Okay. This can be saved here. This is www.google like that. Another one is like this. Okay. It can be yahoo.com. Fine. So database is more efficient here because using hash function, hash map will take more memory, and it is not advisable. It is not cost effective. So using a database will scale up our project and provide us a distributed system that we can store lots of keys around here. Okay. So hash value thing that we are discussed here. So for creating a hash value, we have to decide how many characters do we need. So there are two. There is a small way to discuss to decide that. Like we have around how many IDs that we needed. We needed around 36 billion.
3.6.
In 1 year, we have around 36 billion keys.
Sorry, can you come again?
Yeah, 36.
We have around
Yeah.
36 billion keys for 1 year.
Per year, yes.
Yeah. So to store 36 billion, we need a hash function that will around if it's 2 to the power, we can take 2 to the power 2 will be like 4, 2 to the power 6, sorry, 2 to the power 5 will be around. Let's take how much, how to find that. Mm,
You want to find
not 2 to the power, yeah, yeah. No, it is not 2 to power because we have a long character that we've decided, right? Like alphanumeric. For alphanumeric, we have like 0 to 9, then A to Z, and then
Capital A to
big
capital
Z.
Hmm.
That will be like around 10 characters for 0 to 10.
26.
Then we have
62
26
total 62
plus
characters.
total 62 characters. That now we have to find the value. How many? What is the length of that hash value? Hash value length will be like around 62. So 62 the power n. So calculating this n, we can check how much, what is it returns, like 62 the power 4. Sometimes my Google goes slow. I don't know in which tech world Google living. This is like 4 million. Okay, sorry, 14 million. Okay. And then we have to go up then to reach billion. It is our like around 1 billion. Okay. Yeah. So this is like around 5.6 billion. So I think 6 character is enough for our this to encrypt this 36.5 characters. Okay. So our n value will be 6. It will incorporate around 56.5 billion keys. So now what happened here? There are with hash function there is one more anomaly comes. One, there are pro and cons also. So the con that comes with hash is collision. Most of the time what happens, like while calculating the same hash value can be generated. The same hash value can be generated, right?
Okay.
So if that happens, then it will trigger a hash collision.
You mean different URL can have same
Yeah, can generate one same hash.
Hash value should be unique, right?
Yeah, our need is unique, but
Not sometimes
these are some.
they can be same. Sometimes, yeah, has can be same for different URLs.
So we should handle this collision resolution. So we have one of this. This is our one solution, and the other solution that is used is you can say base 62 conversion. So we will discuss step by step both one.
Base 64 or 62?
Base 62 as we needed here around 62 characters, right?
Okay, okay.
That's why we will convert our URL to base 62. So hash collision is a small solution to handle hash collision. Is like what we can do. Like whenever there is a hit, like a ID exists, then what we add one predefined character to it, or a letter to it, a predefined letter. Like take an example like short URL is a predefined one, and whenever it happens, we will again add up this new one short URL to it to the key, and again track back to the same method. That is like it becomes a long URL, and again it's go to the hash function. It will generate another key. If the key again means exist, we will repeat the same thing.
We will change the long URL.
Yeah, we will keep changing the output so that whenever a unique hash generated, it will stored in the DB. It is something like that. If you want to see, it is like your long URL. Okay. And then it comes to your hash functions. Then it generates you a short URL. Then you will check DB, and this is exist in DB. It is a short URL, and here is your hash function. If okay, stored in your data. Okay, so if it exists, and if it's not, then you will save to DB. And if it's exists, then what you will do, will append predefine a word to it. Okay. And this process keep repeating. And so this is this resolves our hash collision problem, but it brings another complexity. The complexity is always checking the DB for every URL generation. Okay. So this is a drawback here. So that's why instead of using this, we come up with another solution, that is like using base 62. What is base 62? It is a simple notation change. What you can say here. In base 62, what we will do, it is like 0 is 0, okay, then 10 is A, this is the representation, how you will show, how will call yourself. 0 we will call 0, 10 we will call A, then you can say 35 will be called Z, then 36 will be called capital A, and 62 will be called Z. So here what we do mainly in this principle, in our long URL, we will convert our long URL to a unique number. This is our long URL. We will create a unique ID generator. And it is always numeric.
It should be alphanumeric, no? UIDs are alphanumeric.
Yeah, I'm explaining that only. So UID should be like this, numeric, and when this UID go through your base 62 provision, it will become alphanumeric. And I am explaining that in
Okay.
next.
Got it.
Yeah. How it become alphanumeric. Then this is saved to TB. So here, as I have said, this is you are going to convert this long URL to a numeric number. Then this is base 62. It, this base 62 will convert our number to a short URL. Okay. This is base 62. Then this is short URL, save to DB. And here what happened, like you can say our long URL will convert to a number. Number could be like, let's take this 1157. What we will do, we will keep dividing it by 2. Like this is decimal number 1157. If we want to convert it to base 62, we will divide it by 62 and we will keep the remainder. Okay. And if you want, I can show you the calculation. Instead of keeping out here, I will show you in this slide. Yeah. Here you can say this is 1157 divided by 62, 179. That is 59 is the remainder, 62, 55 is the remainder, 62, 0 is the remainder. Okay, as I explained earlier, that 2 is 2, 55 will be capital T, and this is X small t, right? So this will be our new ID, UID, short URL, that is 2tx. This store this as our short URL in the DB. So are you guys with me till now?
Yes, Kundan, yeah.
Do you have any questions regarding this?
मुझे वो वाला रिपीट पे चाहिए, डिवाइडेड बाय 2 वाला.
Okay. As we have taken this an example, na?
2 मिनट फोन करते हैं फिर ना, ये मीटिंग बने. हाँ.
As we have taken an example here, like this is our number. Okay. Let's take like we have converted our long URL to this number. Okay, this unique number. And this unique number we will convert it to a base 62. And to converting a base 62, this is our provision, like 0 is represented by 0, 10 is represented by small a, like 35 is represented by z, small z, and 36 by capital A, and 36 by our capital Z.
This is base 62.
Yeah. So it is simple. Yeah, it is simple thing. Like we have around 62 characters, 0 to 10, then small a to small z, and capital A to capital Z. We will keep in a line, and we are assigning to 0 to 62 below that.
Okay, we are assigning those number to them.
Yeah. Every character we assign a from 0 to 62, we assign a value to that, like something like a sky value. Okay.
Okay,
And
people, I think you can just imagine it as a explain. It can be a key values like 0 for 0, 1, something like this, and then when A comes, it is 10, B is 11, C is something like this. You can remember the hash map with the size of 62.
Yeah, and converting it to a alphanumeric, what you can do for this is decimal number, right? This 1157. To convert it to our base 62, we divide it by 62 and keep the remainders. So these are remainders, and we will convert these remainders to our representation.
Okay. Can we let's do one thing. Let's do divide this in a paper, in a calculator.
Yeah, let's
Yeah,
give a number.
Google calculator we can open Google calculator.
Just give me a number.
Take the same number.
Let's do
13576. Okay.
And 2, 4, 3 more character.
878. Okay.
Okay, ठीक है. Divided by 62.
Okay. So what we will do? We will divide by 62.
We need a percentage. A percent.
Sorry. It should be not divided. It is module
Remainder.
plus.
We are getting remainder, right?
Yeah. 27.
So
okay. Just remember, this is we have to divide, or
we are getting the mode.
Right? What we can do. We can tell it to convert is 10 decimal to base 62. So it will explain us here. When you divide 62 by this will be like 213820 will our output, and remainder will be 27. Then again we divide this output from 62, the 44 will be the remainder, like this way. These are our remainders. Okay, 27, 34, 38, and this 55. Now as we have discussed our representation, you can tell me what are these numbers. 38 comes here, then 55 comes here. Okay, and 27 you can say it is
R.
if
Capital A.
0 to 10, 27 will be
R.
around M,
Is it?
Small r.
And
Small
yes,
r.
okay. Sorry.
and 44 will be I think if A B C it will be H, and this 38 will be around C.
वो नीचे दिया हुआ है step 2 में.
Okay,
हाँ.
okay, 27 is like
हाँ.
maybe it has kept another thing. It taken 0 to 9, capital A to in the middle, small. We have just reversed it. We took the small one in the middle. Our result could be different from it. But this small will be always equal. This is small r. 44 will be our capital I, and this C will be small c, and this will be a capital T. So our output will be
R. I.
R
I see.
I
C.
C
T. Capital T.
Okay, this will be our output. So it is not a. So what happens in base62? It is not fixed. It is like it come up to 2 characters, also 3 characters, up to go to 7, 8, 9 characters. But in our hash function, it is fixed. Like we have taken 6, so it will always return our output as 6. Okay. So here are some example. Differences you can check on, like fixed short URL length. Wait a second. Yeah. Yeah. As you can see, hash collision is fixed. Base62 is of variable size, vary size. Then it does not need a unique ID generator. You can see this is an extra step that we needed in base62, but collision is impossible in this, as we are generating every time a unique ID, and here collision is possible, and but the thing is, it is impossible to figure out what will be the next hash key, because it's all random. And here what happened, you can like backtrack or reverse engineer to find out the URL, so that this could be a security concern. Okay, so based on this, we have to like now find out our solutions. So this much is completed till here, and now after this we have another thing that we have to this is like the generation is completed, right? And next we have to check what it is the uh, redirection. So redirection, I think it is much easier for you guys. Whenever you will hit it, it will come to a like a load balancer. It will uh, in for redirection, whenever the short URL comes to your server, you will keep a load balancer in the front, and load balancer will distribute to your servers based on the traffic, whatever logic, round robin or least LRU you selected, and based on that it will return a location to you. Search the DB and return the location, and this location will go up with 301 or 302 as per your project need. So this is complete, I think. And what other thing we can incorporate it with it? So we can, if we had time in our further interview rounds, we can discuss some of the things like keeping a rate limiter so that no ambiguous hit come to your server. One is that, and the second is like how to scale your server and DB. Okay, so that consistent data stays. And DB shredding you can explain here. Then if you want to incorporate analytics, so you have to store the data, how many times it reached to you, and what part, which areas of the application it got used, like it's used in WhatsApp or in some payment or maybe in Facebook, that you can keep in your analytics. That would be a help. It could be help to your clients. And cap theorem, as we discussed in our last lecture, it can we can see around this also, how to make our servers and our system consistent and available. Now this is completed till now for our URL shortener, and this URL shortener will bring another topic with it. You know what is the topic? Can you guess?
Hash algorithm.
Caching,
Hash, yeah, hash algorithm is one of the thing, but I'm not prepared for that today. You can see here, this is unique ID generator. This is another system design part, how to generate a unique ID. So,
This is UUID is the database ID, na?
sorry.
UUID is the database ID.
You can take database ID. There are different provisions how to use them, because database ID also brings some complexities.
Mm-hmm.
If you keep two databases, right,
Mm-hmm.
in two servers, then there could be a similar ID generated, because the database will start from a number, right? Those number could be similar. So we have to find a synchronization way, so that all database will synchronize with each other, and it will not generate same key, same ID.
Mm-hmm.
So we will come up to that. Before that, I want to show you something. Like I have write a small Node.js and React project to demo this in a working
Okay,
stage.
we can conclude this. Then I would stop recording for this lecture.
Okay. No, I want to show you the website that I have generated using.
So I want to conclude this, and we'll start new recording with this lecture.
Okay.
Yeah.
Please continue.
So you will start in that lecture, right?
No, I will complete in this one only.
Yeah, I understand. The recording I'm stopping for this lecture.
मतलब रिकॉर्ड हो सकता था, ये बोल रहा था मैं.